Here we have a really, you can probably even see it on camera, really dusty SSD. Most of you are probably booting off of something like this. This is a SATA SSD. Maybe you're booting off of, say, an NVMe SSD a few years back, or maybe some of you even today are instead booting off of a spinning metal disk. And if you've been using a computer for even longer, maybe you've used other things in the past as well. Now, you may recall this post from a few years back. Download more RAM, literally. Wait, you can actually download more RAM if you set up Google Drive as swap space. And this person wrote an accompanying blog post about doing this. It was not a good idea, it was really slow, it was stupid, and you shouldn't do it. But you could do it. What if instead of your swap being on a cloud drive, you did something even stupider? What if, again, for the love of God, don't do this. What if you decided to boot off of Google Drive? Now, a normal person would say, why? That's obviously not a good idea. It's gonna be horribly slow. Now, a fun person would say, how do I do it? Now, I'm sure they saw that original swap post, but this was not made directly in response to that. Instead, it was made in response to what one of their friends did. They got a little bit competitive with them. When I heard that a friend got Linux to boot off of NFS, I had to one-up her. I had to prove that I could create something harder, something better, faster, and stronger. And like all good projects, this began with an idea. Not a good idea, but an idea. On the brink of insanity, my tattered mind unable to comprehend the twisted interplay of millennia of arcane programmer time and the ragged screech of madness, I reached into the mass and steeled myself to the ground, lest I be pulled in, and found my magnum opus, booting Linux off of a Google Drive root. Now, there are cheap and easier and hacky ways to do this, like mounting the drive on another system and then network booting off of that drive, and that's technically doing what you're saying, but that's boring, and that's too sensible. I wanted this to remain self-contained, so I couldn't have a second machine act as a helper. My mind went immediately to Fuse, a program that acts as a file system driver in user space. Fuse is a system that is often used for things like app images. It is how you go and mount an Android phone, and there are tons and tons of other uses for Fuse, things that you just wouldn't really think of. Basically, any sort of file system you want to have that just doesn't make sense to be in the kernel because it's just such a weird idea, this is the way it's generally handled. Now, the issue is Fuse isn't exactly supposed to be run at this point. Generally, Fuse isn't being used during the boot process. Doesn't mean it can't be done though. I just had to get Fuse programs installed in the Linux kernel and initramfs and configure networking. How bad could it be? Before we go on, what is a initramfs? From the Gen2 wiki, the only resource online better than the Arch wiki, an initramfs initial RAM file system is used to prepare Linux systems during boot before the init process starts. The initramfs usually takes care of mounting important file systems by loading the proper kernel modules and drivers, such as /user/var, preparing the dev file structure, etc. And then for users who have an encrypted file system, it will also have the initramfs ask them for the passphrase before it can mount the actual file system. So if we're trying to mount the actual file system, and the file system comes from a Google Drive, getting Fuse during this process is exactly what we need to do. With the standard Linux boot process looking like this. Firstly, the firmware, BIOS/UEFI, starts up and loads the bootloader. The bootloader loads the kernel. The kernel unpacks a temporary file system into RAM, which has the tools to mount the real file system. This is the initramfs part. Then the kernel mounts the real file system and switches the process to the init system running on the new file system. So before going all in with this, a proof of concept needs to be done to make sure you can actually have working networking and working Fuse during the initramfs process. So that was exactly what was done. This was built on top of Arch Linux because it's relatively light and they're familiar with how it works, as opposed to something like Alpine, which is probably the way that if you actually wanted to do this, you probably would want to build off of. And rather than starting directly on real hardware, initially this was being done in a container, with the container just having the absolute minimal it needed, having a kernel, and basically just the fuse stuff, and not much else. With absolutely no expectation it was going to work, they started up the container, and it dropped them into a shell. At least initially, it was running. Now at this point, the root isn't mounted. It's just running the kernel, and it should theoretically be able to do more from here. Hacker voice, I'm in. Now to enable networking and mount a test root. I've already extracted an Arch Linux root into an S3 bucket running locally, so this should be easy. Right? I just have to manually set up networking routes and load the drivers. All of the networking stuff, done perfectly fine. They mount the S3 bucket, it looks like it is mounted. Then they do a switch route, and it doesn't work. LS is missing, systemd is complaining about problems. It seems broken. Now, if you're a normal person running a normal distro doing normal things with your computer, I wouldn't be surprised if you've never seen switch root before. What this does is switches to another file system as the root of the mount tree, moving the already mounted proc, dev, sys, and run to new root and makes new root the new root file system and starts the init process. Basically, it's for switching the root you currently have mounted. In this case, it is being used to go from the init ramfs root over to this network root. Everything was gone. At this point, I was stuck and I had no idea what to do. I spent days just looking around, poking at the switch root source code, all for naught, until I remembered a link that a friend of them had sent them. How to shrink root file system without booting a live CD. In there was a command called pivot root that switch root seems to call internally. This was from Stack Exchange. This is one of the very rare occasions now where you don't just have AI asking AI how to answer something, you actually get a proper, well-explained answer. Except for an issue with pivot root. Pivot root is not allowed to pivot roots if the root being switched is in the init ramfs, you know, the thing we're currently in at this very moment. And Stack Exchange answer says to use switch root, the thing that wasn't working. Okay, so what if you just ignore the whole switch root, pivot root thing and just mount it directly and then switch with chroot, so swapping the root over without doing a specialized system call? This almost worked. I need to run chroot command as PID1 so systemd can start up properly. I can actually tweak the init ramfs init script and just put my startup commands in there and replace the switch root call with exec chroot /sbin/init. So after modifying the script and rebuilding the FE image, it looks like it works. It took you to the Arch Linux login. I sit there in front of my computer, staring. It can't have been that easy, can it? Surely this is a profane act, and the spirit of Dennis Ritchie ought to have stopped me. Right? Nobody stopped me, so I kept going. I log in with the very secure password root as the root user, and it unceremoniously drops me into a shell. At last, Linux booted off of an S3 bucket. I was compelled to share my achievement with others. All I needed was a fetch program to include in the screenshot. Obviously, using fastfetch. And then we had an issue. DNS is broken. Also, missing dig and other debugging tools. Wait a minute. My root file system is on S3. I can just mount it somewhere else with functional networking to root in and install all my utilities. Some debugging later, it seems that systemd resolve D doesn't want to run because it failed to connect standard out to the journal socket, ignoring permission denied. I'm not about to debug systemd because it's too complicated and I'm lazy, so I'll instead just use Cloudflare's. Setting up Cloudflare's DNS, And it worked. Downloading things just fine. Here we have it functioning in the proof of concept state. Now to make it really terrible. Now to move it over to Google Drive. Luckily, there was already a Fuse driver for mounting a Google Drive. Google Drive OCaml Fuse. This is not intended for mounting it as your root drive. This is intended to mount it like a OneDrive or a Nextcloud drive so you can access the files on that as if it was a regular drive on your system, or things like mounting a NAS. Not this. This is not the intention. But you can do it. After installing the driver and setting everything up on the Google side to actually have the Arch root on a Google Drive, it seems like it worked. I have Arch Linux on Google Drive. Just kidding, it's never that easy. Here's a non-exhaustive list of problems I ran into. Symlinks to symlinks don't work. Very important for stuff in user lib. Hard links don't work. It's so slow. Relative symlinks don't work at all. No dangling symlinks. Important for stuff that links to proc and isn't mounted, or stuff that hasn't copied over yet. Symlinks to things outside of the Google Drive don't work. Permissions don't work. Neither do attributes. Did I mention it's slow? That's going to become a very important thing a bit later. If it was not evidently obvious, Google didn't intend for you to ever mount a Google Drive as something you boot off of. And this driver never intended for you to try and do that either. So the file system that is set up here is not intended to be used as a drive, let alone a drive you boot off of on Linux. But when has that ever stopped anyone? With how many problems there are with symlinks, I have half a mind to change the Fuse driver code to just create a file that ends in .internal symlink to fix all of that. Google Drive compatibility be damned. But I've challenged myself to do this without modifying anything important. No kernel tweaking, no Fuse driver tweaking, so I'll just live with it and manually create the symlinks that rsync fails to make with a hacky sed command to the rsync error logs. But then there was an issue. chroot/sbin/init file not found. Perhaps they did not bother to stop me because they knew I would fail. I know the file exists since, well, it exists. So why is it not found? Simple. Linux is kinda weird, and if the binary you call depends on a library that's not found, then you'll get file not found. So it's not this that cannot be found, it's something it relies on, but the error message is not clear about that. Why is it broken? Well, we talked about it already. Symlinks are broken, so it's trying to read a symlink, and the symlink doesn't function. Well, that's come back to bite me. The kernel is looking for files in /sysroot inside /sysroot/sysroot. Luckily, this is an easy enough fix. We just need to have /sysroot linked to /sysroot/sysroot without links. And you can do that with the mount command. And now it is time to boot. Or at least it'll be time to boot very soon, because it took Arch Linux 5 minutes to rebuild the dynamic linker cache, another minute per systemd unit, and then nothing. The startup halted in its tracks. Luckily, this is a pretty easy one to deal with. It timed out waiting. So all you need to do is just disable the timeout, set it to infinity. Now, luckily, it didn't take infinite time to boot. It booted. Okay, we're looking good, Tries to log in, and it times out again. This time the login times out. Turns out if your login takes more than 60 seconds, the login's like, I don't know what's happening here, and just times out. Again, luckily, a very easy thing to set, and you can set logout timeout to 0, and it just works. And it did. They logged in, and it seemed like it was working. This is now booting and logging in on a root on a Google Drive. An incredibly slow way of accessing Linux. But with a bit of tweaking, it can be done. However, this is not the end. I am not satisfied yet. Nobody has stopped me because they want me to succeed. I have to take this further. I need this to work on real hardware. For this, they have the perfect victim, an extra laptop that currently doesn't have any storage. There are a few changes that needed to be made though. Use the right Ethernet driver and not the default E1000. Do not use a serial display, and change the network settings to match my house's network topology. And hey, for the hell of it, let's just do Powerline Ethernet, because why not? Is not going to impact performance in any way that matters, and I don't have an Ethernet cord that can reach my room. I build the unified FE image, throw it on a USB drive under /boot/EFI, and stick it in my old server. The server being that laptop which now has no drive in it. Despite my best attempts, I couldn't figure out what the mod probe directive is for the laptop built-in keyboard, so I just mod probed HID USB and used an external keyboard to set up networking. And it just worked. This is my magnum opus, my great work. This is the mark I'll leave on this planet long after I'm gone. The cloud native computer. This is a really stupid project. There are potentially less stupid, I wouldn't say good ideas, but less stupid ways this can be used, like booting over SSH, or booting out of a Git repository and tracking every change in Git using Git-fs. Now, I know this person understands what they're saying here, but for anyone who doesn't, please don't store random binary files in Git, or you're constantly going to be seeing changes. But if there is anything I know about technology, it's that moving everything to the cloud is the current trend. As such, I am prepared to commercialize this for any company wishing to leave their unreliable hardware storage behind and move entirely to the cloud. Please request a quote if you're interested in true cloud native computing. Where does this link to? This actually links to the contact me page. Unfortunately, I don't know what to do next with this. Maybe I should install Nix. If you've done this, I think installing Nix is not really an upgrade and stupid. I genuinely hate this idea so much. It might be one of the most cursed things I've ever seen. But it technically works. So, read the sign. Don't do this. But if you do, send me screenshots, could be very funny, and I would like to see them. So, let me know your thoughts. Do you have any dumber ways you can think of to boot Linux? I would certainly like to know, and if you do, I would like to see a blog post about it because I want to talk about it. Anyway, if you liked the video, go like the video, and if you really like the video and you want to become one of these amazing people over here, check out the Patreon, Scribes, Liberapay, linked in the description down below. That's going to be it for me, and again, don't do this.